Hi, welcome back to Missing Chemistry. This is Intra and Intermolecular Forces lesson. Well, let's look at a couple things here, okay? Intramolecular forces are forces that hold atoms and compounds together. And intermolecular forces are forces that are between molecules that hold them together. Okay, so there are three intramolecular forces. There's covalent bonds, there's ionic bonds, and there are metallic bonds. Now, in the covalent bonds, there are nonpolar covalent bonds. These are nonmetals and nonmetals sharing electrons equally. So that means their valence electrons are being shared equally. Polar covalent bonds are sharing bonds also between nonmetals and nonmetals, but they're sharing these valence electrons unequally. How's that happening? Well, it happens that when these two atoms are sharing these valence electrons, the electrons are at equal distance from both atoms, that one of the electrons are going towards one of the atoms, closer to one of the atoms. While that one atom is getting closer to is not actually taking it, the other atom it's going away from is still holding it, but it's distancing itself further away from the original atom to the new atom. So that's basically what it means by sharing unequally. Ionic bonds, these are bonds that result from taking of electrons from a metal cation and giving them to a nonmetal anion. So when a metal gives up an electron, it has more protons than electrons and it becomes a cation. And when a nonmetal takes on that electron, it has more electrons than protons and it becomes an anion. The last thing is a metallic bond. Metallic bonds are metals and metals, and in these metals they're like at this mass sea of electrons. So think about these metals as the positives here, and these little dashes right here are the electrons. And so you have these atoms, these metal atoms that are like basically cations, and they're in the sea of electrons, and this is how metals are kind of being bonded towards each other. Okay? Now, intermolecular forces are different. They're forces between molecules that hold them together. There are three types. There are hydrogen bonding, dipole to dipole, and London dispersive forces, or van der Waals forces as they're called. Now, what happens is this. When you have polar molecules, like for example, hydrogen bonding is the most powerful of the intermolecular forces. And in the intramolecular forces, the most powerful bonds are the ionic bonds, of course. So let's go ahead and look at the hydrogen bonding. All right, notice that hydrogen here in this dipole, this is a dipole right here, and the electron is going towards the oxygen atom, making the oxygen more negative. These are what we call sigma negatives, right? So they're sharing electrons, but they're sharing them unequally, kind of like a polar covalent bond. Okay, and so what you get is the hydrogen becomes slightly positive. Well, when hydrogen becomes slightly positive, because its electron is drifting towards the oxygen, it is attracted to the oxygen of another water molecule as negative, right? And so then you have this hydrogen bond. Hydrogen is actually bonding to the oxygen. And this kind of goes on and on and on. And all these hydrogen bonds create water droplets, basically. And one thing you need to remember, that hydrogen, again, if it bonds with nitrogen, oxygen, or fluorine, it's considered a hydrogen bond. Now, dipole-dipole. These are polar molecules to polar molecules. So here you have hydrogen, its dipole is going towards the chlorine, so the electron of hydrogen is being dragged towards this chlorine right here, making chlorine more sigma negative, which means chlorine takes on this anion effect, and hydrogen in effect becomes like a cation. Although it's not a cation, because a cation would be a metal, but hydrogen becomes more positive. So this negative chlorine, it's attracted to this hydrogen positive, and vice versa. this hydrogen positive gets attracted to this chlorine, and it creates a dipole bond. Okay? The last but not least of the intermolecular forces are London dispersion forces, or van der Waals forces. These are temporary dipoles. What happens is this. These unshared paired electrons on the end of nitrogen here move towards the other nitrogen. And when they do that, nitrogen on this end becomes positive, and on that end becomes negative, right? So when nitrogen becomes negative, the other thing here, these two unshared pair electrons, they also will drag towards the nitrogen in this way. So they'll go back the other way, and then they makes that positive, and makes it negative. But when that happens, when another nitrogen comes along, this nitrogen end is negative, and this nitrogen is positive, creating a temporary dipole or temporary attraction. These attractions are there 1 minute and gone the next. So that it's kind of like it's just temporary. It's like here and then there, and then it's gone. So that's it for this lesson, guys. You be snarly, and we'll see you back here at Musin Chemistry.